So I'm Sarah D'Angelo from Northwestern University, and I'm going to be talking about research I conducted with my co-author, Andrew Begel, at Microsoft Research on improving communication between remote pair programmers using shared gaze awareness. So people are collaborating remotely in a lot of interesting and resourceful ways. For example, in this image, we see a professional software engineer using Skype with remote desktop to work with his coworkers. And this is a particularly interesting activity for remote collaboration because pair programming is traditionally very dependent on co-presence, enough so that we see people scheduling their work hours together so they can work on the same code at the same time, which makes remote pair programming very difficult. And I just want to clarify, when I talk about remote pair programming, I mean two people separately working on the same piece of code at the same time, unlike distributed pair programming in which two people might be working on the same code base, but they'll have their own unique views. So in remote pair programming, our screens are mirrored. So if remote pair programming is so difficult, why would anyone do it? Well, we conducted an anonymous survey with 159 software engineers at Microsoft, and we see that they do want to work remotely on average about 11 hours a week for various reasons, like avoiding a long commute. However, only 18% of the engineers who have pair programming have tried doing remote pair programming because they don't think our technology is effective enough to support it to the means that they would feel that they were effectively pair programming with their partner. So you can read more details about our survey in the paper, but this motivated us to conduct observations with 3 pair programming teams at Microsoft. And from those observations, one thing that really stood out to us as a barrier for remote pair programming is being able to effectively refer to locations in the code. So we observed that talking about code locations is difficult and awkward when you're working remotely. And this can happen for a variety of different reasons. So we developed a scale on different types of references specific to pair programming, ranging from implicit to explicit. So on the implicit end, you see deictic references, like saying here or this. On the explicit end, you would see something like using a line number or highlighting the text, right? And so this can be difficult. So you maybe can imagine that we're remote pair programming together, and I say something like, this is our shared window, and I say, I think we should change this, right? You probably have no idea what I'm talking about. I can help you out a little bit and say something like, I think we need to change the constructor. All right, I'll give you an abstract concept. But there are a couple constructors on here, and you might not know which one I'm talking about. So I could get a little even more specific and say, I think we need to change the rectangle constructor, but again, which one am I talking about? So I'll try even harder. I'll say we're changing the rectangle on line 1. Again, there are 2 instances of the word rectangle. You might be a little bit confused about which one is a constructor and what I mean, so I might have to then highlight it for you. And that was a lot of work. But we don't see that people doing this in collocated pair programming. It's relatively easy to talk about what we're trying to refer to in the code. So we see people pointing, we see people looking at what they're talking about, and this happens rather naturally. So we thought this would be an interesting opportunity to explore integrating nonverbal cues into remote collaboration, as we think that better tools can help remote pair programming be as effective as collocated pair programming. And this is a really large goal, so this study just takes one step in that direction, using eye tracking to try to bring collocated interactions closer, or remote interactions closer to collocated interactions. So we use eye tracking to design gaze visualizations. So gaze visualization is displaying where your partner is looking on your screen. So you can see where I'm looking, I can see where you're looking, and we have this shared workspace. And prior work has shown that showing you where your partner is looking in remote collaboration can help us coordinate on collaborative search tasks, it can help us discuss problem solving, and it can be used as an effective referential pointer. So I might say, hey, look at this, and you might have a good idea of what I'm talking about because you can see where I'm looking. However, most of the prior work has explored displaying gaze visualizations as a single point like you see here. So you just see a dot that represents the coordinate of where I'm looking on the screen. And this can be distracting for a variety of different reasons. Natural eye movements happen very quickly. We're constantly scanning the space. So this dot might be moving around your editor very quickly and might be disrupting you from the task. Eye trackers are also inherently imprecise due to noise and microsaccades, which are just very fast, quick eye movements. So you're getting a lot of input. It might not all be accurate, and that can contribute to these distracting effects. So one thing that you could do is you could highlight a large range of text that you're looking at, right? And that's what we initially thought we would do to help alleviate some of these distracting effects. But as you can imagine, changing this many color pixels on your screen while you're trying to code can be very distracting, and that's what we found. And you can read more about our design process in the paper, but we wanted to explore using a design visualization that's specific for pair programmers that isn't distracting and relatively unobtrusive. So our final visualization looks something like this, where you see we kind of moved that long highlighted bar just to the left-hand margin near where the line numbers would be. It's 5 lines high by 20 pixels wide. And this helps us do a lot of things that were an issue with previous gaze visualizations. So this helps us smooth the movement. If you're looking anywhere within that rectangle, that line is not going to move, which is nice. It accounts for error. Specifically, eye trackers have more error on the y-axis than the x-axis, so this long vertical span lets us account for that error. And it's relatively unobtrusive, so it's just sitting on the side. It's not coming into contact with the text that you're trying to edit. It's just kind of over there. And we also display shared intentionality, so this shared understanding that we're looking at the same thing. So this visualization turns green when the programmers are looking at the same area of code together, so I know that we're both here. And this is what it looks like in practice. You can see the large Visual Studio window behind you, and in the zoomed-in box is a closer view of our visualization. So it's rather subtle, but it effectively shows you where your partner is looking in your shared code base. So this motivated us to ask the question, which is how does displaying gaze visualizations affect how remote pair programmers refer to locations in the code? And to answer this question, we conducted an experiment with 12 professional software engineers. We had them do a short refactoring task. So they were asked to clean up code for the game Flappy Bird, if you guys remember that. So they had a good time doing this task, and it was all in one single file of code. And we had them do 2 refactoring tasks of equal difficulty. We do a 2x2 design that is within subjects, so every pair did a refactoring task with and without the gaze visualization, and the ordering of these was random and counterbalanced. And our setup looks something like this. So again, this is kind of our proof of concept experiment. It was a low budget, so people are not actually remote. They're pseudo-remote. We have them in the same room, so we don't have to worry about any lag time in their communication, but they cannot see each other. We have the displays connected to the same computer, showing a mirrored Visual Studio editor. They both have their own eye trackers, which are sending their gaze coordinates to the other computer or the other display. And each of them have their own keyboard and mouse, so they can make edits in real time, and that is reflected for their partner. And this is, again, designed to replicate the Skype with remote desktop experience. So here's an example of what it looks like in practice. You'll see the programmer in the upper right. His screen is in the upper left, but his gaze is displayed on the window in the lower left. And I'll play this video for you really quick, and you can see them talking about moving a piece of code.
So we have it here. We don't have it anywhere else, so we can safely move it where it was here.
So you see at the end, they've kind of decided on the location of the code. The block is turning green, showing that they're looking at the same thing together, and they've successfully moved the piece of code to a new area. And you might have noticed a couple of deictic references in there. But let's look at this across pairs. So our first question was, how much time did pairs spend looking at the same area of code together with and without the visualization? So you can see in this bar graph, you see the lighter gray bar is showing with the gaze visualization, and on the right, you see without the gaze visualization is a darker bar. So we see that they're spending significantly more time looking at code together with the visualization. So this is suggesting that they're acting more tightly coupled, which might be a good indicator of good coordination. But again, this result just tells us that when we showed them where their partner was looking, they did tend to look there more often. So we wanted to explore this a little bit deeper, and we look at what types of references were used by the participants. So this is the same scale that I showed you at the beginning of the talk, ranging from implicit references to explicit references, and we see that with the gaze visualization, that pairs are making more deictic references than without the visualization. So we're saying more things like here or this. And then when we look at the specific words, we tend to make more specific word references without the gaze visualization than with it. So when I can't see where you're looking, I might use more specific words like player height, which is interesting, right? This is maybe more indicative that they're talking like they would if they were co-located, because now they can see where their partner is looking. But this might also just mean that we're talking more effectively. Does it mean that we're actually communicating more successfully? So we looked at how successful references were made when they were communicating. So we checked if they were successfully acknowledged. So if I made a reference and you said something like, yes, I see, or you looked at what I was talking about, that was coded as a successful reference. If you never acknowledged it in any way, if you expressed some sort of confusion, that was an unsuccessful reference. So we see that pairs are making significantly more successful deictic references with the gaze visualization compared to without the visualization. So when I say things like here or this, you know what I'm talking about when you can see where I'm looking. And we don't see a change across the other types of references. So we're not really changing the way people are communicating when they use other forms of references, but specifically to these deictic references, saying here or this, we do see this improvement. And so we also wanted to talk to our participants and get a sense of how they felt about this new visualization. And consistent with prior work, we see that participants are using the visualization as a referential pointer. So one participant says it can be a replacement for pointing. So you might use a gesture in collocated work, and in collaborative work, you can use our gaze visualization to indicate what you're looking at. We also see that participants preferred using this type of visualization compared to maybe more traditional methods of using line numbers. So one participant said, I usually use the line numbers, but I would prefer to use eye gaze if it's available. So they do like using this method to communicate about locations in the code. We also see that participants appreciated the shared intentionality that was designed in there. So they noticed that when it turned green, they were able to identify that they were looking at the same code as their partner and talking about the same code. So they felt like they were both working on the same line of code together at the same time. And we also see that participants didn't report this visualization to be distracting. So one participant said, I think the bigger thing for me is not where he's looking all the time, but where does he want to have me look? So I'm not constantly distracted by the presence of your gaze in my code, but when you want to have me look somewhere, I can quickly refer to this visualization, and I know where to go because I know what you're trying to get me to look at. And that was really exciting for us because that was one of our big motivations for exploring new ways to design gaze visualizations. So in summary, we see that programmers looked together more often when the gaze visualization was displayed compared to when it wasn't. They communicated with more deictic references and were more successful at communicating those deictic references with the gaze visualization compared to without. Participants felt that the gaze visualization helped them communicate with their remote partner, and the design of the visualization was well suited to the context. So this is particularly interesting. We designed this for remote pair programmers using Visual Studio. It's a kind of a text-based interaction, so this line numbers and this left-aligned visualization was really appropriate for that context. You can imagine a lot of other designs that might be more appropriate for different types of contexts, and I think the design space for these gaze visualizations is an exciting opportunity for future work. And so with that, I want to thank you on behalf of myself and my co-author Andrew, and I'll leave the summary up for questions.
Hi, Jimmy Lin from Google. I really like this work. I was wondering if you had thought about adding in yet another condition, which is actually co-located pair programmers, and then see how that compares with the other two.
Yeah, so we thought about that, and that's an interesting question. One thing that we were really interested in doing is tracking their eyes during this, and so far it's not easy to put two people in front of the same monitor and track them both at the same time, so we wouldn't have that comparison to be able to put this visualization with co-located programmers, so it didn't seem like it would be quite the comparison we were looking for, but that's something that we want to do, and we're currently exploring ways to track two people on the same computer, so it's a good point.
Hi, Michael Koblenz, Carnegie Mellon. Thanks, very interesting. I know that you said that the participants didn't say that it was distracting, but I wonder how this approach would compare to a similar approach where you only showed the other person's gaze when they activated some sort of affordance, maybe mitigating some of the distraction if there is any. Or on the other hand, do we have sort of concrete evidence that there was no distraction?
Sorry, can you repeat that again? Did you mean?
Or maybe do we have any evidence that there actually wasn't any distraction at all? It seems like it has to be a little bit distracting, but maybe that's wrong.
Yeah, we didn't specifically ask if it was distracting, but we did conduct a survey after to ask if it was useful, and no one said that it wasn't useful. We don't see any people saying that they were distracted by it. In our design process, we do explore more subtle versions of this, and we see people ignoring it. We then had the other scale, which was too distracting, so we tried to fine-tune it, and through our pilot tests, we did ask, do you find this distracting? And when we hit that balance of over in the corner and slightly opaque but not too opaque, people reported from our pilots that it wasn't distracting. But for this experiment, we don't necessarily have a way to compare other forms, but I think the idea of partially available gaze visualizations is really interesting, and maybe only using it when you're making a reference would be a really interesting avenue for future work.
I guess I wonder how this would compare with an even simpler, even lower budget approach of just show where the other person clicks when they click. So if you want to say, look over here, then you can make the person look over there.
Yeah, so that's an interesting question that I think about a lot. So in the study, we do show their participants when they highlight text. So if I clicked on text, you could see that with and without the visualization. And we see participants doing that. But what you see is that we still see the same differences when we add on the visualization in addition to clicking. So I don't think it's mutually exclusive. I think they kind of they can complement each other. And I think gaze is maybe a more kind of unintentional signal. So you might get some value from, I want to know where you're looking, but I don't necessarily want to ask you what you're working on, and I can get this kind of implicit signal. So I think they can work together. But I do agree with you. Directly selecting text is like a more precise way. I just don't think that they have to be separated.
Okay, thank you.
Mm-hmm.
All right, thank you very much to Sarah, and thank you everyone for coming to our session.